So, assuming the distribution of heights of adult men is normal with mean of 174 and standard deviation of 7. So if you've got your normal distribution curve, then what you should be looking at now, mean of 174 and standard deviation of 7. So 174 as my mean, and my standard deviation comes out to be 7. Now it says, find the probability the randomly selected adult man is under 185 centimeters. So 185 centimeters is going to be somewhere around there, and I want them to be under that. So the first thing I need to do is to convert it into a standardized score. And in our standardized score, we know that the mean is always 0 and that the standard deviation is 1. And to get our standardized score, we take our value, which is 185, you minus the mean off it, and then divide by the standard deviation. And that should give you your standardized score. So in this case, the number that we're going to be looking for is going to be 1.571. Now to find 1.571 and to find phi of 1.571, and remember phi of 1.571 gives me the area from 1.571 all the way down, which is going to be exactly the same as the area from 185 and below. So using our tables, we'll scroll down a bit, we want phi of 1.571. So there's 1.5, there's 1.57, and there's 1.571. So I take this value and I'm going to add this number to it, so I should have 9419. So phi of 1.571 equals 0.9419. And so to two significant figures, the probability in this case that x is less than or equal to 185 is going to be 0.94 to two significant figures, 0.5942 to 3, so on and so forth. So the adult man selected at random under 85 is 0.94. To work out the probability that the man is over 185, so we'll change colour, so that's the probability that the random man is over 185, well that's going to be 1 minus the probability of him being under 185, which was phi of that, and so I'm going to have 1 minus 0.9419, and that's going to come out to be 0.0581. So to two significant figures, they're 0.058, and that's the probability that the man is over that. Now remember, that bit there that we've just discussed being over is going to be this area here. Now for the next part, we want to know what the probability of a man being over 180 centimeters is going to be. So this time I'm going to start with a fresh one. You can always worry about the one that you used. So we have our middle bit as 174. Our standard deviation was 7, and this time we're looking at 180. Notice the diagram is pretty much identical to the one previously. The 180 is pretty much in the same place. It really doesn't matter. It's only a little sketch to help you find out what you're looking for. Now the question wanted over 180 centimeters, so that means I'm going to look at this area here. Now the tables, remember, don't have that area, they always have less than, so what I'm going to do is find out the yellow section, and since the area under the curve is 1, I'll just take it away from 1. So the first thing I need to do is find my standardized score. So Z is going to be my value, which is 180, minus the mean, 174, and then divided by my standard deviation of 7. So the Z value that I'm looking for here is 0.857. So I then look up phi of 0.857 and find out what that is. So 0.8 is here, 0.85 is there, and 0.85, what was it, 7 is there. So I need to take this value and add to it that number. So 32, 42, 8042 is what I'm looking for. So that will be 0.8, what was it, 8042. Now that means the bit in yellow is this value. So that number represents that value. So remember, our mean in the Z world is 0, our standard deviation in the Z world is 1, and the value that we've just looked up in the tables is that one in place of the 180. So the probability that x is greater than 180, and I'll turn back to blue actually, is equal to 1 minus the probability that x is less than or equal to 180, which is 1 minus 0.8042, comes out to be, what's that, 0.1958. So that's 0.20. Correct two significant figures. And it does ask us to give all our answers to two significant figures. I probably hadn't done earlier. So part 4, between 180 and 185. Now that's made a little bit easier because I've got my 185 values here. I've got my 180 values there. So what I'm going to do is just pause this. Very Blue Peter-esque. And now that I've got this up, I'm going to put all of this on my diagram. Again, I like to do a new diagram each and every time. Notice all the stuff I'm filling out. You don't need to fill out everything on here. However, I tend to because I like it. So 185 I'll stick at there. 180 I'll stick at there. And what I'm going to do is, I'll use orange here, is if I find the area that I'm highlighting in orange, which we already know from the previous question, the probability that x is less than or equal to 185 came out to be, let's scroll up, less than or equal to 185 was 0.9419. 0.9419. Then if I look at the bit in, we'll go in white, which is the probability of being less than 180, which is that area there, and that area there came out as, in the previous part, probability of less than 180 was 0.8042. 0.8042. That's the probability that x is less than or equal to 180. So the chance of it being in between those two values should in theory be 0.9419 minus 0.8042. So this area that I'll highlight in yellow should come out to be, what's that going to be? 0.1377. So again, round it to two significant figures. And that gives us the value for that bit there. So for the last part, we're looking at under 170 centimetres. Now remember, if I put a new diagram on, then I've got my 174 there, so 170 is going to be on this side, and that will be under 170. Now, if you remember back from a previous video, which I've not actually done yet, you should know that you can't have values on this side of your diagram. So at which point what you need to do is flip the entire thing, and so actually what you're then going to do is find out values on this side. You're going to do the mirror image. So the area in blue should be the same as the area in yellow, and we can work that out. Now, obviously I'm not going to do it with these numbers. Technically, if I want to do it, I'd be looking at 178. I'm going to do it with my standardized numbers. And my standardized numbers, which I'm always writing in green, that gives me my standardized score being 170 minus 174 divided by the standard deviation, which comes out to be 7. So that means the score that I'm looking for is minus 0.571. So this is minus 0.571. So this number that I'm actually going to look at will be 0.571 plus. Now, on our tables, we only actually have positive values. We don't have any negative values at all. And if you remember back from the previous bit, if I want to work out the upper end, so this bit in light blue, I had to do 1 minus the bit in yellow from here. So I'm going to do the same principle there. So what I'm going to do is my tables will give me this area here, which I'm highlighting in light blue. I can then do 1 minus that to get the area in dark blue, and then that should be the same as the bit in yellow. So this area here should be, and I'll do it in blue the same colour, this should be 1 minus phi of 0.571, and that should in theory give me the value that I'm looking for. So 0.571, 0.5, 0.57, 0.571. So I find where these two cross, and I can't read it because I've just written over it. Find where these two cross, and then I add on 3 to it, so that should be 7160. So 1 minus 0.7160, and then that should give me 0.284. And remember, the blue area is exactly the same as the little yellow area here, so this area should be that. Yeah. Let's check anything else.